Hi everyone. In the last lecture, we studied about breadth first search and depth first search. I hope you have done the dry run for both the algorithms. Okay, what we are going to see today as the first thing is how do you find the number of connected components in a graph? We have seen that whenever a graph is disconnected, it has a number of connected components. So how do you write an algorithm which gives you the number of these connected components, rather an algorithm which returns you what are these connected components? So not just the number, finding what are these components. So how you can do that is a simple modification to that algorithm which we have already done before. So we have done an algorithm. So it can be either a breadth first search or a depth first search. The input to this algorithm is a graph and a vertex u from that graph. And as we have seen, the output of this algorithm is all the vertices which you can reach from u. As an example, let's say this is a graph. We have A, B, C, and D, and let's say D is connected to E. If we run a BFS on this graph, so if I run BFS of G, comma, and let's say I start from A, the output will be A, B, C, D, E. And if we run a DFS from the same graph, taking A as the starting vertex, again the output can be A, B, C, D, E, or it can also be A, D, E, C, B. This is one plausible output. A, B, C, D, E is also a possible output of DFS in case you first go in this direction, then this one over here and this one. That we have already discussed. So what we have to do is we have to look at what do we add at the top of this algorithm for BFS and DFS such that we get all the connected components. So given this much is given to us. Okay. So what we can do is we also know that whenever we do a BFS or DFS, we have maintained an array which tells us whether a vertex is visited or not. So initially visited of I was false for all I in V of G because no vertex was visited. Then if I'm starting my traversal from vertex U, the visited of U was set to true. And as when you run a BFS or DFS, as soon as you discover a node, you set the visited of J is true. So what is happening in this particular case? Let's say again, this is the graph, something like this. And I am running a BFS. Let's say the starting vertex is A. So initially none of the vertex is visited. So the visited is false for all of these vertices. Now since I am starting from A, this one will be set to true. Now again this algorithm will run and first we have B and C. So this will be set to true. Next we have D and E. So these two will be set to true and then we have G and this one will be set to true. So after you run this BFS or DFS, for all the vertices which are reachable from the starting vertex A, their visited becomes equal to true. What we are doing here is now we just put this entire thing in a loop. So let's now take a graph which is disconnected. Say we have this graph is a disconnected graph. It has two components. One component is this, another component is this. So initially visited of I is false. For all the nodes, their visited is false. This CC here, it will maintain the different connected components. Next, U. In U, we take the first known visited vertex. So we have a list of vertices in the graph, which is A, B, C, D, E. A, B, C, I don't have a D, sorry, A, B, C, E and F. So you take the first known visited vertex, which is A in our case. So U becomes A. And then you set the visited of U to be equal to true. So this one becomes true here. Then you run a BFS or DFS starting from A. So what do you get? You get A, B, C. Right. So this vertex is reachable from A. This set S here now is A, B, C. For all of these vertices, visited is set to true, and we append this to the connected components. So now the connected components, the first element of the connected components becomes A, B, C. Next, again we look for the first known visited vertex. Now B and C are visited, so E is picked. So now the value of U becomes E. Visited of E is set to true, and you again run a BFS or DFS starting from E. Your set S becomes EF, and this is your second connected component. And for both of these now our visited is true. Again you try to find out which is the first known visited vertex in your graph, and since all the vertices are visited now, you return this list of connected components because you don't have any vertex now which is not visited, right? So what we have done is we have just added a simple loop at the top of our BFS or DFS procedure in order to find the connected components of this graph, which also gives us the number. The size of this list is the number of our connected components.